Lucid is a software tool designed to increase unmanned air vehicle operator situation awareness. Lucid is implemented as a plugin to Raptor X. Lucid adds 3 panels to the Raptor X screen: the Asset Panel, the Event Panel, and a panel for creating areas of interest. Lucid also augments the track visualization, highlighting events and fading old tracks. Lucid's key technology is Computational Situation Awareness, or CSA. CSA maintains situation awareness to aid the operator. CSA detects important patterns called events. There are 3 different categories of events: task events, user-defined mission events, and failure events. Events are prioritized and shown to the user in priority order. CSA also estimates the operator workload. When the user is overloaded, CSA offloads events and related assets to a secondary operator. Now, we will show Lucid in action. A carrier group is operating off a coastal area. The mission is to find, identify, and track specified ground and sea targets. There are 2 bomb sites, to the west and the east. There is a training camp. There are several docks in the port. The mission is to find and track any vehicle moving from the bomb site to the training camp. Find and track any vehicle moving from the training camp to the dock. Find and track a specific vessel, called the Trojan Steed, coming into port. Determine whether there is a meetup between the training camp vehicle and the Trojan Steed. Find and track any threats to the carrier group. At the beginning of the mission, the primary operator decides to send a Triton to observe the sites of interest. The primary operator gives the secondary operator command of 2 assets to monitor shipping lanes. The secondary operator uses these assets to investigate ships near the harbor. A destroyer is discovered, and Lucid notifies the secondary operator. The operator asks Lucid to monitor the area around these threats in case a UAV drifts too close. Meanwhile, the primary operator is investigating tracks highlighted by Lucid as being possible high-value targets. As the UAVs execute their tasks, the operator is notified of tasks being started and completed. One of the assets runs low on fuel. Lucid notices that the primary operator is heavily loaded and hands this event to the secondary operator. The secondary operator commands the asset to return to base. Lucid alerts the primary operator to a communications loss with the U-class asset. The primary operator sets up a restricted zone, so he will be notified if the asset drifts into this poor communication zone again. The secondary operator is inspecting and marking sea tracks, eliminating those that cannot be the Trojan Steed. The primary operator is similarly eliminating ground tracks. The secondary operator notices a destroyer moving in toward the fleet and has a fire scout follow it. 2 air vehicles drift too close to the destroyer, and Lucid alerts the operator, who directs them away. At this time, the primary operator is busy in a different sector, where a U-class has had a navigation issue and is drifting out of the area of operations. The U-class is sent back to the carrier group. The secondary and primary operators coordinate to positively identify the Trojan Steed based on its visual attributes. The mission continues, focusing on ground tracks. From this vignette fragment, we see how Lucid is helping the user orient to the critical mission information and balance workload across the team. An evaluation of Lucid with 4 Navy reservists using this mission vignette showed Lucid reduces interaction time with the operator control unit and with the other operator. Lucid increases time spent on harder tasks, in this case the ground tracking task. Lucid increases the user's perceived situation awareness and actual, measured situation awareness. Lucid can be a very valuable addition to an operator control unit, helping the operator to orient to mission challenges and make better decisions.